Alright, in this video we're going to be talking about the difference between exponential growth versus decay. If you do have your journal out, something you want to do is you want to kind of make a sketch of this graph and then a sketch of this graph. And when you're looking at exponential functions, you're always looking at them from left to right. So make sure you always read the graph from left to right. And if we interpret this from left to right, we can see that this is what's called growth. It's growing, okay? This is what we call decay, or it's shrinking because it's going down. So when you're dealing with an exponential function, the growth factor is always going to be your b value. So if you have a function y equals a times b to the power of x, if the b value is greater than 1, that means it's going to grow. And if the b value is less than 1, but greater than 0, so basically any fraction, not an improper fraction, but a regular fraction like 1/3 or 1/2, 2/3, etc. All right, it's going to be going down. Let's look at our b value. Our b value is right there, which is 8/3. Well, 8/3 is greater than 1. So since that's greater than 1, I know I'm going to have what's called growth. I know that's a fraction, but that's an improper fraction. It's actually bigger than 1. Okay? If you don't believe me, you can do 8 divided by 3, and so you get 2.6 repeating, so it's 2 2/3, which is greater than 1. Okay? So if it's greater than 1, it goes up. That's it. Hey, look, you got a fraction. That fraction, that's less than 1. That means it's decay. Here's your b value. It's a 3. That 3 is bigger than 1. Therefore, it's growth. There's a fraction. That fraction's totally less than 1. It's 0.42857142857142857. All right, which is decay. You're like, what are you talking about? 3 divided by 7 is 0.42857142857. Well, that just rounded from a 5 to a 6, but that's what calculators do. All right. So, wrong page. I'm not advertising. So that's going down. And that's all I have to do on that one. So graphing is a little bit more complicated. It's not that bad. By the way, this is your horizontal asymptote. Always keep it at 0, okay? Because right now nothing's being added or subtracted. So always just leave that. Don't mess with that. But if you want to graph this, I'll show you how to graph it. And I'm not even going to use a graphing calculator. Now you can use Desmos if you want to, but this is very, very, very easy. They see that number right there? That's my a value. And that number right there is the b value. But the cool news about all exponential functions is that the a value always is your y-intercept. So I know I'm going to start with a 0 and a 9. So right up here, it's going to plot a 0 and a 9 right there. So I always know I have a point right there, 0, 9. Now if I plug in a 1 right here, here's what I got. 9 times 2/3 to the power of 1, which is just 9 times 2/3. Well, 2/3 of 9 is 6. Because 3 goes into 9 is rule of 3 times, and 3 times 2 is 6. That's one way of looking at it. The other way of looking at it, you could do 9 times 2, which gets you 18/3, because 9 times 2 is 18, and 18/3 is also 6. So I'm going to put a 1 and a 6, and those are the 2 points that I'm going to use. So 0 and a 9, and a 1 and a 6. There we go. All right, so let's say you guys don't like the by hand way. Well, you can still type it in to Desmos. It's not that bad. This takes a little bit longer because you got to literally type it in exactly as it appears. Let's see, 2 divided by 3. Go to the right, close parentheses, the power of x. All right, so there. So then you can check your points and go, hey, I'm checking my points. There's a 0 and a 9 and a 1 and a 6. So you could plot them without having to do it in your head. Okay, so that's what I did. In case you're wondering what I did, that's what I did without Desmos. Okay, that's going to be your y-intercept. Okay, so I'm going to go over and do the next one. Oh, wrong one. Graph. There we go. Hey, what's my y-intercept? I think it's at an 8. You're right. Then all I got to do now is just plug in a 1 right there. So if I have 8 and I do raise it basically to the power of 5/4 to the power of 1, that's just basically what's 8 times 5/4? Well, 4 goes into 8, a total of 2 times. And 2 times 5 is 10. So if I were to make a little table here, when x is 0, y is 8, because remember, that's my y-intercept. And if I plug in a 1, I get a 10. So I'm going to do a 1 and a 10. Put that one there and that one there. That's what I'm going to do. Hopefully that wasn't too fast. If it is, just rewind and see if it makes sense. All right, now, for those of you who don't like this method of that's your y-intercept and just take that number and simply multiply it by your fraction to get your next value, then you go to Desmos and you go over here, you put an 8, and then you put a 5 and a 4, because people just don't like doing math in their heads anymore. And you got 0 and an 8 and a 1 and a 10. So you can plot your, well, there it is, 110. All right, let's go back to graphing. Hey, what's my y-intercept? I think it's at a 2. You're right, it's at a 2. And what's half of 2? Hopefully some of you guys are saying half of 2 is 1, dude. You're right, half of 2 is 1. So I've got a 0 and a 2, and I've got half of 2, which is a 1, and that's all you got to do. Hey, what's my y-intercept? 2. You're right. And then what are we multiplying that by 1 time? 3. So we're at a 1 and a 6. If I'm going too fast for you, I'll do it one more time. I'll do it nice and slow for you to see what I'm doing. I look right here. That's my a value. My a value is always my y-intercept. So I'm at a 0 and a 2. That's why I plotted that. And then I plugged in a 1. And if I do 2 times 3 to the power of 1, that's just 2 times 3, which is a 6. I got a 1 and a 6. And voila, I'm done. 1 and a 6, 0 and a 2, and that's it. So now we're going to go to the more complicated one, which is writing exponential decay. All right. So there's going to be certain things that are decaying in your lifetime. One of them is if you buy a car right off the lot, then it's going to start decaying. All right. If you buy a mobile home, that's very hard to keep. That will depreciate over time. It's going to be decaying. Oh, your teeth. They slowly decay over time. All right. Oh, when you die, your body, your remains decay over time. All right. Hopefully, the coronavirus, like the COVID, like the amount of people that are getting infected, hopefully that'll go now. Hopefully it's going down instead of going up. Hopefully that'll decline. Okay. Now, here's where students don't understand what it means to lose something. Okay. If you lose 1/10, that means you actually are keeping something. If you lose 1/10 of your car, what do you get to keep? 9/10. Now 1/10 is like 10%, and 9/10 is 90%. And the decimal for 10% is 0.1, and the decimal for 90% is 0.9. Okay, so it says write a function that gives the car's value years after it's sold. So what is it starting out with? Like, what's my A value? My A value is 5,000. But what's my B value? My B value is not 1/10. My B value is either, you could put 9/10 or 0.9. So I'm going to put 5,000 parentheses 0.9 raised to the power of t. And that's going to be my answer. So if you lose 1/10, remember you're keeping 9/10. 5,000. It's losing 1/10. That means it's keeping 9/10, and we're just raising that to the power of t because it says t is years. All right, let's do 3 more and we'll call it a day. All right. It says at the moment of a certain medicine is injected, its concentration in the bloodstream is 120 milligrams. That's my a value. Okay. So if I'm making a function, y equals a times b to the power of x, starting with 120. Now I got to find my b value. From that moment forward, the medicine's concentration drops by 30%. So if it's dropping 30%, what is it keeping? It's keeping 70%. So if it keeps 70%, that decimal is 0.7. So I'm going to use the decimal 0.7 as my b value. Understand, when you have what's called exponential decay, your b value is what you keep. It's not what you lose. Okay? And I'm going to raise that to the power of t for our problem. Okay, so instead of x, I'm going to put a t. So it'll be 120 parentheses 0.7 to the power of t. Exercises, right? Sorry, a student was asking me a question. Okay, so a forest has 800 pine trees, but a disease is introduced that kills 1/4. So that means it's losing what population size? It's losing 1/4, and hopefully you guys are smart enough to, you're been taught enough that 1/4 is 25%. So what are you keeping? If you lose 1/4, what do you get to keep? 3/4, which is 75%. So we have 800. It's killing 1/4, so it means it's keeping 3/4. And you can also use fractions in this too. So you could also, this correct answer would be 800 parentheses 3/4 to the power of t. All right. I'll do 3/4 instead of 0.75. I just want to make sure you guys know you can also do this, okay? There we go. Last one. Last one. I know I have students who are wanting my help, and I'm trying to get there, so it's not going to be that hard. Last problem. It says the computer sells for $900, but then it's losing 30% of its value every single year. So this starts out with 900, but it's losing 30%. So if you lose, I know it's getting old, but hopefully you see what I'm doing here. It's losing 30%. So what do you get to actually keep? What value does it keep? 70%. And this is where it gets frustrating as a teacher. I do this over and over and over again. But right here, what do students keep putting there instead of the right number? They keep putting the 0.3 instead of the 0.7 because they don't know what it means to keep stuff. They just know what it means to lose stuff. That's my answer. And that's called exponential decay. Okay? Just remember, when you walk into a store and it says 20% off, you still have to pay 80%. Or if it says 30% off, you still have to pay 70%. So if you lose 30%, that means you still keep 70%. And that's it. So hopefully this video was helpful, helping you guys write functions with exponential decay. Right now, my Algebra 2 students are wishing this was their problem.